All right, so now we're going to be evaluating some functions using the hyperbolic functions, just like we did with trig functions. You would take sine of something and find out what it is. So we're going to take and find the hyperbolic sine of the natural log of 4. And what that means is we're just going to plug it into our function. So I like to rewrite the function, especially when you're getting used to these. And then that way you can just see exactly what it is. So in this case, our x is the natural log of 4, so that's what we're going to be replacing it with. So the hyperbolic sine of natural log of 4 would be e ln of 4 minus e to the negative ln of 4 over 2. And then now we can use that rule with logarithms and bring that negative in, and so we end up with e to the ln of 4 minus e to the ln of 4 to the negative 1. See, there's a 1 in front, all over 2. So using our natural log and e rules, this would become 4 minus, and then 4 to the negative 1 is 1/4, so that would become 1/4 all over 2. And then now we can just multiply everything by 4, so this would be 16 minus 1 over 8, and then that way it gets rid of that. So 16, 1, and 8, and then this is 15/8. And we can check this with our calculator to make sure it's perfectly correct. All right, so to do that, you want to find your catalog, and it's right here. So second catalog, and then we're going to find S, so that you can scroll for a long time to get the S, but you can use the letters. It's A, B, C, D, E, F, G, H, I, J, and so on. So there's S right there. You see it? So if I hit this, you see now you now go to S, and then I just scroll down until I see there's I. Perfect, right there. So that is our hyperbolic sine function. I hit enter, and then ln of 4. Enter, and you notice it's a decimal, so I just go math, fraction, so enter, enter, and 15/8. Matches perfect. All right, so now what we're going to do is actually find all the other trig functions for each of these given once. If you remember doing this with trig, where we were given one ratio and you got to find the other 5 trig functions, we're going to do the same exact thing. So remember, our same rules apply here. So if you know cotangent, it's not copying for some reason on some of these. It's just weird when it prints. If you know cotangent, flipping it would give you tangent. So we already know that tangent is 12 out of 13. It's just the reciprocal of them. And then now we can move on to secant. Well, do we see anything with tangent and secant? Yes, right there. So it says 1 minus tangent squared x equals secant squared. So we can say that 1 minus tangent squared x is equal to secant squared x. Forgot the h. And now we just plug it in. So 1 minus 12 over 13 squared is equal to that. And so this would be 1 minus 144 over 169. And so this subtracted would be a difference between them. So what's 169 minus 140? So like I was saying, if you just take these two and subtract them, it tells you the numerator, 25. Or you can actually subtract it in your calculator. But we get 25 over 169. Square rooting both sides, we would get plus or minus 5 over 13 is equal to secant, hyperbolic secant. Now, hyperbolic secant is the reciprocal of cosine. So if you remember, the hyperbolic cosine is always positive, which means this is also positive because you're just reciprocaling it. So we get 5 over 13, and then now we know that it's 13 over 5. So now all we have left to do is find the hyperbolic sine, and then use it to find the hyperbolic cosine. Well, do you see something that we can use for that? Yeah, it's right there. Hyperbolic cosine minus hyperbolic sine is equal to 1. So hyperbolic cosine minus the hyperbolic sine is equal to 1. And you always double check your identities. I already know it's true, but, well, I didn't put the h, so it's technically not true. But you always check them to make sure, because if you make a mistake, well, you just wasted your time. So I got to put the h back in there. Okay, so now I can plug in my hyperbolic cosine, which is 13 over 5. And then now I'm just going to have to solve to find hyperbolic sine. So I'm going to do a quick little switch. This is 169 over 25. minus 1 equals the hyperbolic sine, like that. So I just move that one over, move that one over. All right, so same idea. It's just 169 minus 25, which we know is 144, or again, you can use it to find it. So we get 144 over 25 is equal to our hyperbolic sine. So that means our hyperbolic sine here is 12 over 5. Now there was a simpler way of doing it as well. So you can see we always focus on this side and forget these. So if you look, there's hyperbolic tangent is sine over cosine. Let's try it that way. So the hyperbolic tangent is the hyperbolic sine over cosine. And so if we take those two values and plug them in, so the 12 over 13 and the 13 over 5, you can do a little cross multiply. So we're going to just multiply this by this, and then that would equal our sine, because this would just be over 1, and so on. So hyperbolic sine, oops, don't need a division line there, equals 12 over 13 times 13 over 5, cancel, cancel, it's 12 over 5. This method also works better because we know that tangent's positive, cosine's positive, so it takes care of it for us. Over here, we'd have to look at that situation and you think about it. So here we have a positive or negative. Well, tangent's positive, cosine's positive, so together that means sine has to be positive because tangent is sine over cosine. So 12 over 5. And then for our hyperbolic cosecant, we just flip it, and there you have it. So there are our other 5 hyperbolic trig ratios.